right, welcome everybody to Standing for Truth. My name is Donny Budinsky, and I am your host for today's program. On Standing for Truth, we uphold the truth of biblical creation. We also host some awesome guests here on the program to assist us in this important mission. Now, it is a privilege, as always, to have Michael J. Oard back with me this evening to do just that. Mike is going to be revealing the truth about ice cores, and I'm excited for this. This is going to be another valuable presentation for myself and also for you in the audience. Mike is an excellent researcher, and he has blessed this ministry with so many educational presentations. These talks include the rapid formation of caves, the receding floodwaters, the Ice Age, answering challenges and refuting objections, the Green River Formation. We've done a whole series together on flood boundaries, the Missoula Flood, the Grand Canyon, and more. So if you're new to this channel and you want to check out those past presentations, please do check the description box of this video where you can find links to Mike's websites. You can find his material over on creation.com as well. And I have several of his books behind me. His most recent, if I'm not mistaken, being Biblical Geology. And so, okay, what I want to do before we get into our presentation for this evening is give Mike a formal introduction for anybody who might be unfamiliar with who he is. Michael has a master's science degree in atmospheric science from the University of Washington and is now retired after working as a meteorologist with the U.S. National Weather Service for 30 years. He has researched and speaks on the compelling evidence for Noah's flood and the ice age that followed, and how the incredible woolly mammoth connects to biblical history. Michael has published many papers in his field in widely recognized journals and has written An Ice Age Caused by the Genesis Flood, Ancient Ice Ages or Gigantic Submarine Landslides, the Missoula Flood Controversy, and the Genesis Flood and the Frozen Record. He is also author of Frozen in Time, The Weather Book, and Life in the Great Ice Age. You can find this introduction and more from Mike in the description box. Now, today's presentation is titled Ice Cores Explained After the Flood, the Simplified Version. Now, why we are doing this specific presentation is we've put out a comprehensive presentation, more technical presentation on this same topic going back somewhere between 4 or 5 months ago. So I'll make sure that is linked in the description box. We want to have the best of both worlds. So now we got a more simplified version for you as well. But as always with these programs, we're going to have a discussion and audience Q&A time after Mike's presentation. So please, if you do have a question, do your best to tag me at Donny, and we'll have some fun interacting with those. Okay, Mike, it's great to have you here on the Standing for Truth program. As always, brother, tell us, how have you been?
Oh, I've been well. Enjoying the winter while the snow flies.
Well, it's a perfect time to do a show on ice cores and the Ice Age in light of how cold, snowy it is for you and I, Mike. So I'm looking forward to this. This is an important topic.
Yeah.
And so let's just hand it over to you. I'll get your slides up. Mike, whenever you're ready, just let me know.
Okay.
And, okay, the floor is yours, Mike. Go ahead.
Okay. Earlier, as Donny said, I did a in-depth presentation. This time, I'm simplifying it, and I'm only going to answer 3 major challenges, which I will list here pretty soon. But we are challenged by Hugh Ross and Bill Nye, the Science Guy, and others. This is a quote from Bill Nye, the Science Guy, when he was debating Ken Ham. He said this, referring to ice cores. Let's say we have 680,000 layers of snow and ice in 4,000 years since the Great Flood. That would mean we would need 170 winter-summer cycles every year for the last 4,000 years. I mean, wouldn't someone have noticed that? Wow. Wouldn't someone have noticed that there's been winter, summer, 170 times in 1 year? You know, statements like that betray his ignorance of ice cores, to no other way to say it. First of all, there aren't 680,000 layers in the Greenland or Antarctic ice sheets. You don't have seasonal layers on East Antarctica. You do in West Antarctica, but nowhere near 680. In West Antarctica, the new waste divide core that only shows about half the ice age, believe it or not, you only go to about 40,000 years within their time scale. 40,000 layers, they claim. But those claims, I believe, are spurious, and I'll give you reasons for that. Hugh Ross says something similar to that. Studies of ice cores affirm the antiquity of the Earth and pose a serious challenge to young Earth models. Layers in ice cores, those are cylinders about that wide of ice removed from an ice sheet, can be used to determine ages if the layers are deposited annually. Assuming annual layering, high-resolution ice cores from Greenland and Antarctica give ages in the hundreds of thousands of years, indicating Earth is at least that old. That's a totally false statement. They do not give hundreds of thousands of annual layers. In the Greenland ice core, they claim 110,000 annual layers, which I will get to soon. But Antarctica, especially East Antarctica, has no annual layers. The reason for that is the ice is too thin and it blows around at the top. And there are annual layers, like I said, in the West Antarctic ice sheet, but it only goes only in about 39,000 years. He goes on to say, recent work conclusively demonstrates that events occurring on century and millennial timescales in both cores correlate with each other. Oh, they do not. They're quite different. Millennial scale oscillations are quite different between the two ice sheets. In fact, you don't even really pick up millennial time scale in East Antarctica. Furthermore, the cores show variability matching periodicities in Earth's orbit that occur on a millennial timescale. Earth's orbital periodicities, which I will show you when I get to the Milankovitch mechanism, are not on millennial timescales. They're on tens of thousands of years timescale, and there's huge problems with the Milankovitch mechanism. In fact, they assume the Milankovitch mechanism when they date the East Antarctic ice cores. I'll get to that. These results corroborate the strength of RTBs as reason to believe's old Earth model, but presents an awkward fit if they can be fit at all in young Earth models. Skeptics need to do their homework. That's all there is to it. I could say a lot more. But let's get to the talk. Here's the three main challenges I'm going to go over. How do 110,000 annual layers in the Greenland ice cores be explained? How is 800,000 years in Dome Sea East Antarctic ice core explained? I got to distinguish between East and West Antarctic because the ice cores are much different between them. And number three, how such thick ice is explained within the biblical Earth history. How can we explain 3,000 meters of ice in biblical Earth history? Well, you'll see. Well, let's do a little survey of ice cores. I believe this is up to date. They got quite a few cores, as you see. The latest one is this East Grip core, but the more popular ones are the GISP-2 core and the Grip core. The GISP-2 core, they're both drilled on the top of the ice sheet, the highest point, and they go down to the bottom. The GISP-2 core was drilled by the US and the Grip was drilled by the Europeans. And here's the Camp Century core. That's the first core ever drilled in the mid-1960s, Camp Century. I'm pointing these out because I will show you a profile of these. Well, let's jump to Antarctica. Here's East Antarctica here on the right. And it's very thick, much thicker than the West Antarctic ice sheet over here. And here's the Waste Divide core and the Bird core. Those are the two main deep cores. There's a few small cores. I will say something about the Bird core. In fact, I'll show you a profile of it. Of note, on the East Antarctic ice sheet, you have the Dome Sea. That's the main ice core that everybody refers to that supposedly has 800,000 years in it. And here's Vostok. I will show you a profile of that too with time. And here's other ones. They just drilled a new core called Little Dome Sea. And the core barrel was about like that. New technology, went all the way to the bottom in 4 years, but I haven't seen any analysis of it. They claim it reached 1.2 million years. But I have a feeling the arguments I use for Dome Sea will be the same for Little Dome Sea. Okay, there's 4 conventional ways to date a core. Annual layer dating, which skeptics think that that's the main dating method. Actually, it's not, even in Greenland, as I will show. Glacial flow models. I'll show you pictures of this. As the ice collects in the bottom, each layer moves down and it flows out towards the ocean. And they give a timing on that by reference horizons or tide points. Usually those two go together. Number 2 and 3 go together. And then the 4th method is comparing the Milankovitch solar radiation cycles. That's the 4th method. So I'm going to quickly go over the methods, and then I will get into the answers to the 3 main questions. First of all, annual layer counting. There's actually 3 types of annual layers based on the seasons, different seasons. Oxygen isotope ratio, or the deuterium isotope ratio, oscillations going down the core. Differences in acidity. And then number 3, cloudy clear bands called visible stratigraphy. Those are the 3 seasonal or annual cycles that they use for the Greenland ice cores, and even in the cores in West Antarctica. So here's kind of a rough sketch of a seasonal layer. Here's the oxygen isotope ratio right here. And in summer, you get the depth ore complexes that cause cloudy bands. Also, you get more sulfuric acid in the summer. And then in the winter, you get more dust and also more sodium from sea spray caused by stronger winds, and more calcium that caused by stronger winds coming from land. So those are the main seasonal cycles that are used. There's lots of other seasonal cycles, but those are the main ones used. And here's the main one, oxygen isotope ratio, which is, actually I got this reversed. It should be more negative. No, I have it right. It's more positive in the summer, more negative in the winter. And so here is a profile of the ice core called Milcent that only went to about 300 meters. And you can see the oxygen isotope ratio. Winters are to the left, summers are to the right. So it oscillates pretty good. And you can see we're near the top of the core, 1970, 1960, 1950. So those are nice oscillations for winter and summer. So that's one of them. Here's the cloudy clear bands that you pick up of visible stratigraphy. So I talked about annual layer counting. Now I'm going to talk a little about glacial flow modeling and reference horizons. The way it works is as your snow piles up on the top, it has an annual layer on Greenland. It's about 25 centimeters at the top, which is thick enough to show an annual layer because diffusion tends to wipe it out, but it'll keep the annual layers as each annual layer goes down in the ice and it flows out. And they assume the ice has been in equilibrium about the same height for millions of years. That's an assumption they've made. Antarctica built up in the early Oligocene, about 35 million years ago, and reached steady state about 50 million years ago. These are rough numbers. They always are changing. The Greenland ice sheet is thought to be a couple million years old, but then they claim that it could be as much as 30 million years old. But regardless, it's been the same essentially for millions of years. And these are the flow lines. And tide points or certain horizons date it. Notice that the blue is kind of a schematic of the thickness of that annual layer. And as you get down further in here, it's compressed more and more, and they get thinner and thinner until you get near the bottom. They're about as thin as a dime, maybe a millimeter or two. You might think that it might be tough to find annual layers when they consider them only about a millimeter thick near the bottom. Yeah, okay. So the way it works is as more ice is piled on, one annual layer gets compressed and it deforms out to the right and left. And the annual layer, now it'll show storms in there, that annual layer. But because of the compression and something called diffusion that smooths the annual layers, smooth the storm out, you get some nice annual layers. That's sort of how it works. And like I've already said, this comes with assumptions. Ice sheets have been about the same height for millions of years. The ages of the tide points are determined from other data sets that also assume old ages. So they have a whole chronology that they expect before they even look at an ice core. You might think it might produce an element of circular reasoning in there. Indeed, it has, and I will show that. What are some of the tide points? The end of the Ice Age, about 10,000 before present. The Younger Dryas, an oscillation right before the end of the Ice Age. The Eemian Interglacial, or the Sangamon Interglacial in the U.S. Eemian's a European term, and that's about 120,000 BP. And they correlate the East Antarctic cores with marine isotope stages, abbreviated MIS, M-I-S. Also, they have a lot of volcanic markers. For instance, the Great Toba eruption claimed at 73,000 years. So let's take a look at some of these tide points. They're hardly ever published, but they did this new rice core right here. That was drilled on an island in the this Ross Sea here that's covered by sea ice out to this point right here. So it's a new core, and it only goes to maybe 70,000 years in their time scale, not even one ice age cycle. So here's the tide point. I expect you to absorb all this, but you can see the more recent ones. These are the dates right here on the left where the cursor is, like Krakatoa. There you go. That's a tide point. Yeah, that's a good tide point because we have a good date on that. Let's see. Here's another one from West Antarctica. Here's more tide points. a New Zealand one, 236 AD. But you'll notice that most of them are unknown. And beyond about this one right here in 236 AD, you don't find any. But then here we come to the Younger Dryas. That's the date they give to the Younger Dryas. That's stamped on the flow model. The flow model is adjusted to agree with it. And here's all these events on Antarctica called terminations. You might notice, see, this core only goes to about 88,000 years. I mean, not even one ice age cycle. Their ice age cycle starts about maybe 100,000 years in the ice cores in their time scale. Notice the Toba eruption is totally missing in this. It's not a tie point. Well, it's claimed in others, so what gives? I think there's a lot of manipulation and fudging going on in here. So I talked about the annual layer counting, glacial flow models that are used with reference horizons or tie points, and it's all compared to the Milankovitch insolation changes, that's sunshine changes. So I'm going to give a little lesson on the Milankovitch or astronomical theory of the Ice Age. Anyway, you see plots like this in the literature. This is out to 1 million years, and it's from 65 degrees north, solar radiation at the summer solstice in watts per square meter. And that would apply to June 21st, one day at 65 degrees north. Look at the oscillations. There's various scales, types of oscillations, which they use spectrum analysis to tease out the dominant ones. But you can see how it oscillates pretty good. And it looks very impressive. And because of this, we have thousands of papers published in the literature assuming the Milankovitch mechanism is true. But hardly anyone ever goes back to see what this is all about. The last ice age ended 10,000 years ago. So this is this low solar radiation point right here. And then it melts at this high. So here's the last peak of the last ice age right in there. I'm going to say a little more about that. So they do spectrum analysis, and here's the cycles. They get 100,000 year cycle, and they get which corresponds to the eccentricity cycle that's of the Earth that changes the orbit will change from almost a perfect circle to slightly flattened ellipse over 100,000 year period. Then we have the tilt cycle, where the tilt changes by 2 degrees with a period of 43,000 years. And then we have two processes, which are essentially, you can think of them as the precession of the equinoxes, which are, they average about 22,000 years. I'm not going to say anything about these other cycles, only the 100,000 year cycle, because that's the main cycle that's used in ice cores. Now, when you, the trouble with plotting the radiation at 65 degrees north for one day is totally deceptive. This is, you got to talk about the whole season. And this is a plot of the caloric summer northern hemisphere, which is the warmest 6 months of the year for summer. And by the way, that 65 degrees north is assumed to be summer solar radiation. And you can see that here is that where the ice age formed. And the peak of the ice age was in here. and this caused the melting in here, this above normal. But notice that in 6 months, that it varies a lot by latitude, a lot. And so notice that 65 degrees north is up in here, but you go down to lower latitudes, there's hardly anything. And you got to include the whole latitude and the whole 6 months. So let's pick 85 degrees north. And here is the solar radiation change, but this is for a whole month, which is just maybe a little better than 1 day, but still, it shows these big, nice oscillations. At 20,000 years, about the peak of the Ice Age, you had the cool oscillation. But if we included the whole 6 months, it smooths out to be only slight oscillations at 85 degrees north. And if we included all the latitudes, just not 85, but all the low to mid latitudes that have hardly any effect, the Milankovitch mechanism is only maybe about 1 to 2% changes in solar radiation, a very small change. And meteorologists have pointed this out for years because this is an old theory from the 1800s, and it was rejected for almost 100 years, but then it got resurrected again in the 60s and 70s based on ice core, deep sea core dating that had a lot of assumed ages in it. I believe there's a lot of circular reasoning in that. Anyway, that's the Milankovitch mechanism. So let's get to the challenges. First challenge: how are 110,000 annual layers in the Greenland ice core explained? Well, we do it by annual layer counting. Here's the GISP-2 ice core. Right here, it's about 3,000 meters thick. And this is the oxygen isotope ratio, which is a lot of variables affect oxygen isotope ratio, but in general, it's correlated to temperature. So these are the ice. This is the ice age portion where it was cooler. This is the post-ice age ice. Notice all these great oscillations in here. That's where you get those so-called millennial changes that are very abrupt and catastrophic. And it's fueled the global warming hysteria because they think that can occur today, but it can't. It doesn't occur after the Ice Age. It's an Ice Age phenomenon due to the unique climatic effects of the Ice Age and only the Ice Age. You can't use it for global warming today. So a plot of that is it shows an Ice Age, and the early part of the Ice Age shows warmer temperatures, and then after the Ice Age. This is exactly what we expect with the post-flood rapid Ice Age. One Ice Age that started off mild, cooled, and then melted. So Greenland only shows one Ice Age. This is exactly what we expect. And since each Ice Age is about 110,000 years, you might ask, where's the evidence for hundreds of thousands of millions of years there? They thought they could see it at the bottom of that ice core, but they made some mistakes in doing that. But it's not there. They're not there. Interesting. So here's back to the three main seasonal cycles I've already gone through that we'll use for the GISP-2 core. Oxygen isotope ratio, oscillations, differences in acidity, and cloudy and clear bands. So how did they do? The oxygen isotope ratio actually quit at 300 meters deep. That's totally surprising. Why should that occur? I don't really know. They would have used it, I'm sure, but there must have been some reason. I just haven't found it yet. The acidity layers mainly are in the post-ice age time, because during the ice age, you have a lot of dust, and the dust will interact with the acid, and so you can't use it for the ice age. But there's a problem with acidity layers, is that you not only have a seasonal cycle, but you have a lot of volcanic eruptions that cause acidity. So you got to be able to separate those, and whether they think they can or not, I don't know, but I say they have a problem. But regardless, number 3 is their main annual layer dating method, cloudy clear bands, which accounts for 90% of the time anyway. Yeah. For instance, here is the oxygen isotope ratio down the Camp Century ice core. You could see that the ice age portion is not very large, and then it's warmer at the beginning of it. But that's where all the time is. So this is the time scale. There's that top layer right there. And so this is the ice age right in here, starting off warmer and cooling with time, exactly what we expect in the post-flood rapid ice age. And they can only date this by cloudy clear bands. And there's a sample of them in the new E-grip ice core in northeast Greenland. The problem is there's too many of them. So how do you know which is the annual layer and which isn't? You use the flow modeling and tie points to get a rough estimate of the annual layers, and then you go in and pick the visible, the clear cloudy bands that you believe are annual, when there's other ones in between. Here's a quote that got messed up in my PowerPoint. It was okay. Mies et al. 1997, who actually was the group that dated the 110,000 annual layers in this special issue of the Journal of Geophysical Research, Atmospheres. She says, however, an increased particulate concentration may not be restricted to the spring or summer. And additional influxes of dust may occur during any part of the year, creating additional peaks of a non-annual nature. So she admits that there's non-annual there. Another quote, I have lots of quotes. I had to only use 3. More often than not, however, the annual visible signal in the data is ambiguous. Oh, really? And when considered in isolation, these are not easy to use for layer counting. The data is at such high resolution that it may resolve individual precipitation events. That's storms. The cloudy clear bands are picking up storms also, besides the annual layer. Well, how can you tell the difference? Well, by the flow models, the tie point that rubber stamp old ages in the Greenland ice core. And a more recent quote from the literature called the Cryosphere, the journal The Cryosphere, from the E-grip's new core, says our visual and chemical investigations show that cloudy bands are more complex and diverse than previously thought. Okay. Cloudy bands are commonly interpreted as storm events. Oh, wow. In spring and summer, transporting large amounts of dust from Asian deserts across the Greenland ice sheet. Oh, they're picking up storms. So, annual layer counting really failed, and they used these other 2 methods, glacial flow modeling and reference horizons, and the Milankovitch mechanism. How did I know that? Because the GISP-2 core was first dated to 85,000 years to 2,800 meters by Mies et al. And you can find the references in my material, 1993 and 1994. But it was too young based on method 4, the Milankovitch mechanism. So Mies et al. 1997 states it plain as day, by the way, in this journal Geophysical Research. So she increased the resolution of the instrument called laser light scattering from 8 millimeters to 1 millimeter. And guess what? There's wiggles at all scales within this data. And guess what? They found 25,000 more annual layers between 2,300 to 2,800 meters, the bottom 500 meters. And the GISP-2 was dated at 110,000 years. Here's how this is a schematic, and here's how I think they happen. With the 8 millimeter resolution, here it oscillated and you got 10 annual layers. But when you gave a resolution of 1 millimeter, you have a lot more wiggles. And each one of these is an annual layer. That's how they did it. I believe it's due to circular reasoning. The whole thing is a vast circular reasoning network. How do we explain that? They're dating storm and even within storm oscillations. As a weather forecaster for 30 years, even in a storm, you have oscillations in precipitation and snowfall. So these can be, and cloudy clear bands would oscillate. So you'd have numerous oscillations. So when the ice accumulations is meters per year, which we believe is how fast it build up in the ice age, the oscillations from storms and within storms would not be diffused out. It would not be smoothed out. I see my PowerPoint's messed up. It was fine when I went through it. I don't have the bottom, but oh well. So they go to this flow modeling, and the annual layers become thin as a dime near the bottom. But we have a totally different view. At the end of the flood, there was no ice. At least Hugh Ross and Bill Nye got that right. It's after the flood. So you start with 0, but it builds up with time. So instead of being in steady state for a long period of time, it starts from 0 and goes up through the ice age of about 700 years, up to about a year. But then after the ice age, it's still, conditions are conducive to it for it to rapidly, to grow a little more. And then there's been steady state since sometime after the ice age. And as far as annual layers, here's the uniformitarian model. Starts about 25 centimeters and goes down to very thin near the bottom. But we believe in meters per year. That'll be the third challenge I'll go into, is why can we really explain meters per year? Here is a drift from a blizzard in Minneapolis. And you can see that there are clear snow and cloudy snow bands. So this can happen on the Greenland ice sheet. This drift is about 1 meter thick. And can't help but put a weather map up there. Here around Christmas, almost 2 years ago, a blizzard. Anyway, to understand that the storm layers will be there when you get meters per year of annual ice accumulation, here's a schematic of the oxygen isotope ratios. And we'll say this is 25 centimeters from here to here. And here's your storm oscillations. And some of these oscillations in storms are as great as the annual layer. That's well known. There's a warm sector, there's a cold sector. So they'll have widely different oxygen isotope ratios. And as the annual layers press down as it gets further down in the ice sheet, and diffusion smooths it, you end up with this. You diffuse it all out, and just the annual layer is there. If the snow was annual layer was 25 centimeters thick, but what if this was 3 meters thick? That same pattern would not get diffused out, and it would be imprinted there still. And so they would count each one of these wiggles as an annual layer, but for us, they're storm layers or within storm layers. So that's how we can account for the so-called annual layers of 110,000 years. It's, in other words, it's circular reasoning based on assuming the Milankovitch mechanism is truth when it's not. Second challenge, this is actually a lot easier to understand. How are 800,000 years in Dome C East Antarctic ice core explained? Well, here is Dome C, as I showed earlier, and here's Vostok. Vostok is a Russian site, and it's been drilled for a long, long time. They've drilled it many times. They finally reached the bottom. They actually stopped because there's actually a lake below Vostok. But Dome C, they've drilled that all the way to the bottom. But since I'm on Antarctica, I want to show you a West Antarctic ice core. The bird core is the second core drilled. And they have both the oxygen isotope ratio and the deuterium oxygen isotope ratio. They're correlated. But you can see you got a warm sector in the bottom, the ice age part, and then a post-ice age part that's warmer, just like in Greenland. They're very close. Okay, we'll get back to Vostok. Epica means Dome C. Anyway, the bottom panel shows a comparison between Dome C in the red and Vostok in the green. And so they're a little more than 3,000 meters thick. But when you plot it on the top scale by time, the Dome C is stretched way out. And the Vostok core only goes about halfway. Why is that? Well, it's because of these big oscillations. Right here, this one, this one, this one, this one. But these oscillations are a lot smaller, which is disconcerting for supposedly being oscillations that are correlated with the 100,000-year Milankovitch cycle. But anyway, the reason why Vostok isn't as long time-wise as Dome C is because they drilled it above a lake. Here's a Lake Vostok. There are dozens of lakes in the bottom of the Antarctic ice core because the ice sheet is at the pressure solution, so there's a lot of meltwater on the bottom. Lake Vostok is quite large. I think it's 600 meters deep, something like 80 kilometers long. So that's why you only picked up maybe 4 of those big oscillations I showed you. So how is Dome C dated? Unlike what Bill Nye and Hugh Ross say, it's not dated by annual layers. There are no annual layers. Why? Because the snow accumulation is only maybe about 5 centimeters a year. But even that is uncertain. It can be 15 or it can be 0. And it blows around and mixes. So you got to have fairly thick amount of snow to show up an annual layer. So their quotes are totally off base. It shows a lack of scholarship. You obviously cannot date by any radiometric methods. So how is Antarctic dated? Well, you saw those oscillations in it. Antarctic cores are dated by matching those oscillations. I call it wiggle matching. They match these wiggles to deep sea cores. Deep sea cores have the same sort of wiggles. There are more of them, though. So and all this is matched to the 100,000-year cycle and the astronomical hypothesis of the Ice Age, the Milankovitch mechanism. And I might add that the 100,000-year cycle in the Milankovitch mechanism has almost zero influence in the solar radiation. The other cycles, the tilt and the precession of the equinox, are much greater. So this cycle has near zero power. This is a big conundrum for the conventional scientists to explain all this. But regardless, they think it's dated to 100,000 years, so they just simply match the curves from the ice cores to the deep sea cores to the Milankovitch mechanism. In other words, it's a circular reasoning, totally circular reasoning. Oh, I should have shown this slide earlier. Like I said, it's developed in the 1800s, projected for almost 100 years, revived in the 60s and 70s. And an ice age has oscillated every 100,000 years for the past million years, they claim. So they see that there's 8 ice ages in Dome Sea, even though the lowest 4 are really weak. And you can make a case that it's not so, even in their scheme. So here's a quote. I give several. The bottom of this got taken out. Anyway, it says this quote is initial orbital dating, that's your Milankovitch mechanism, in ice cores was inspired by orbital dating of marine cores, that's your deep sea cores. And they give you a reference, Embry and Embry 1980. And guess what? Assuming that the Milankovitch theory that Milutin Milankovic developed and published in 1941, linking ice volume and high latitude insolation, is correct. They assume the 100,000-year cycle is correct, a cycle that has no power, and they use that to date deep sea cores, which are since wiggle matched to date ice cores. It's a huge circular reasoning. There are no 800,000 years in the East Antarctic ice cores. The big takeaway, they simply dated the big wiggles as every 100,000 years, assuming the Milankovitch mechanism is true. But there's huge problems with that mechanism, as I showed you. The third challenge, okay, how can such thick ice be explained within biblical Earth history? I've shown, well, it built up from 0 from the flood. And I showed you this, it's in meters per year. 3 meters is just an educated guess. It could be more than that, less than that. So how do we explain? Well, there's key features of the Ice Age climate. The Ice Age started with much warmer oceans, maybe averaging 30 degrees centigrade for an average, top to bottom, pole to pole. The significance about this is the warmer the water, the much more the evaporation. You could evaporate 7 times as much water vapor into the atmosphere at 30 degrees centigrade as you can at 0 degrees centigrade. By the way, 0 degrees centigrade is not the freezing point of seawater because of all the salt. It's more like minus 3 degrees centigrade. Also, it results in much more snow over the land. It causes a rapid ice age and the rapid buildup of the Greenland and Antarctic ice sheet. Well, how can we develop this a little more? Well, this is the procedure. We will examine high snowfall areas today. We will understand the difference between today and the Ice Age climate. and include the effects of the warm ocean. Anybody ever seen this before? Being from Washington State, I saw this all the time in the Cascade Mountains of Washington. The Cascade Mountains of Washington, Oregon have the world, are tied as the world's highest snowfall area in the winter. This actually is from Northwest Japan, which is also it's about the same amount of snow as the Cascade Mountains. Now, not all that is ice. You compress it, and the ice should probably only maybe about 2 meters of ice, of pure ice in there. But anyway, you get heavy snowfall. Well, we'll take the Cascade Mountains. I'm more familiar with those since I'm from Washington State. And I'll take Mount Rainier's snowfall. Mount Rainier has the world record snowfall in 1 year, which is much greater than their average, I might add. So here's the statistics for the months October through March and the total. This is the water equivalent in meters. And you can see it's about a little less than half a meter in the snowiest months of November, December, and January for 2.17 meters of water equivalent. And here's the depth, the average snowfall depth, 14.2 meters. That's even higher than that picture I showed you from Northwest Japan. That is about 40 feet. So that's Mount Rainier. And they pick up their moisture from the North Pacific Ocean, which is, and like I said, the ocean water is not very warm. And so therefore the evaporation is not great. Besides, there's other factors that would improve the evaporation if they work, but they don't in the North Pacific. So they don't really get heavy evaporation off the coast, but you get the lift up the mountain called orographic uplift on the windward side of the mountains. It drops a lot of precipitation just by the lifting up of a mountain. So we can boil down the snowfall into a little more digestible understanding. Here's that 14 meters of snow depth. And no, 14 meters of total precipitation. Snow depth is only 6 meters because it's compressed with time. Excuse me, that's more like 20 feet. But when you melt it, you get 2.17 meters of water. But since ice is less dense than water, it's about 2.5 meters of ice over the winter. That's what you get. So you might think that, yeah, it is possible under the right conditions that Antarctica and Greenland could get heavy snow. Well, we can go into it even a little bit more. Air rapid evaporation occur when the air is warmer. No, I got it wrong. The colder the air than this sea surface temperature, you get more evaporation. Like when cold Arctic air blows over the Great Lakes, you have massive evaporation. And when you hit the land, you get massive snow. It's called the lake effect. And the drier the air, the faster you get evaporation into it. And the stronger the wind, the more the evaporation. Now, these would be pretty weak off the Washington coast in the North Pacific, where Mount Rainier gets its moisture. The air and the sea surface temperature are about the same. The air is not very dry out there, and the winds are of moderate strength. So let's take the 3 snowiest months of Mount Rainier, which average 0.45 meters of water equivalent per month. Those are the 3 snowiest. But during the Ice Age, you can have a perpetual winter. You can have 12 months of this. So you got to multiply that by 4, and you get 5.4 meters of water equivalent. And ice equivalent would be about 6 meters. So just based on Mount Rainier, all year round, with not very conducive temperatures for evaporation offshore, you can get 6 meters of ice a year. Starting to get it? And so with the warm ocean, you can have the warm ocean offshore. So these are postulated isotherms, average isotherms for Antarctica. -10 inland, and remember, it's higher up in here, so you're going to have a great orographic effect. Also, your 0 would be close to the ocean, and then soon out you get back to 30 degrees centigrade. Well, the warmer the water, the more the evaporation. Off the Pacific coast for Mount Rainier, it's only 10 degrees centigrade. Oh, but these new conditions, you can get a lot more evaporation, a lot more snowfall on Antarctica. And storms essentially go around Antarctica. Sometimes they go out. West Antarctica start off with about mostly ocean. So the storms would go around Antarctica, sometimes go around West Antarctica. Over and over, you get storm after storm. And you'd have colder, drier air in some parts of the storm that would blow off the continent onto the warm water for massive evaporation the closer to the coast because of the warm water. And that evaporation cools the water sinks, and warmer water is always being replaced from further north so that the warm water is close to the ocean, and you get huge evaporation. So you're going to get much more than 6 meters a year. How much? Well, let's go to the carrying capacity of water vapor at 100% relative humidity. There's as much water vapor you can get in before it condenses. This bottom graph here is 10 degrees centigrade. That's the approximate temperature of the North Pacific off the Washington coast. And so you get, you can only carry up to 9 grams per cubic meter of water vapor. But at 20 degrees centigrade, you get about 17. At 30 degrees centigrade, you get about 30. You get much more possibility of water vapor in the storms going around Antarctica. And here it is 10 degrees centigrade, you get 9 grams. And using Mount Rainier as an analog, 6 meters a year. At 20 degrees centigrade, you get 17.3 grams, which equals 12 meters a year. At 30 degrees centigrade, the warmest temperature of the ocean, which would occur at the beginning mainly, you get 30 grams, can equal 20 meters a year. Imagine that. So Antarctica can build up rapidly during the Ice Age. And then as the Ice Age is tailing off, the accumulation slows until we get steady state, somewhere about 2,000 years after the flood. Steady state to the present. And here is a curve, ice accumulation rate. You'd start off from around 20 centimeters a year, decreases with time because the ocean is cooling off, to 10 meters, 5. By the end of the Ice Age, you're down to about what it is today, about 1,000 years. Is there any evidence for these warm temperatures of the air and the ocean? Indeed, there is. This is a cirque formed during mountain glaciation. This is in the Colorado Rockies. And there's cirques found in the high mountains under the Antarctic ice sheet, like the Gamburtsev Mountains. There's cirques about at the elevation of 2,000 to 3,000 meters above sea level. They're pretty high mountains. By the way, they're pretty fresh looking. They're hardly eroded as one would expect if the ice was been there for millions of years. Very sharp, but they have these cirques. What does that mean? Well, meteorologists will tell you that for cirques to form, you need warm, the temperature is pretty warm still at the lower altitudes. Here is a reference from Rose et al., early East Antarctic ice sheet growth recorded in the landscape of the subglacial mountains from Earth and Planetary Science Letters, 2013. They quote, based on the search, we found that maximum, minimum, and average coastal temperatures of Antarctica of 27.8 degrees centigrade, 16.3 degrees centigrade, and this is the max, min, and the average is 21.6 degrees centigrade. Water and air, they would probably be end up being close to the same with time. 21 degrees centigrade. Whoa. Huh. This is powerful evidence for the biblical ice age and the rapid formation of the Antarctica as well as the Greenland ice sheet. In summary, there are no 110,000 annual layers in the GISP-2 ice core. It is based on circular reasoning. The 800,000 years in the Dome sea ice core is also based on circular reasoning. It is dated by using deep sea cores, which are dated by assuming the Milankovitch mechanism, mainly the 100,000 year cycle that, unfortunately for conventional scientists, has almost zilch effect on the solar radiation. Taking into account the unique ice age climate with warm ocean, we can account for ice accumulations of meters per year during the ice age. And if you want to know more about it, this is a technical monograph on that subject, published about 20 years ago. Soon to be published will be a layman-friendly book on ice cores. Should be out any day, published from Creation Ministries International. You can look for it on creation.com. I'm expecting it any day. So the end, and I'm open for questions.
Mike, as always, excellent presentation. What I really appreciate about how you organize your presentations is the way you'll present the challenges first. You'll steelman the other side, as in you'll accurately represent what their arguments are, what their challenges are. And so you make that clear. And now the audience is in suspense. Okay, look at these challenges. They seem like they might contradict a young Earth.
Yes.
And then you go into answering the challenges and showing the circular reasoning within the challenges. And you also show why the challenge is actually for the evolutionists and uniformitarian or actualists to explain the mechanisms for their multiple ice ages.
Yeah.
So I appreciate
I've been getting better over the years.
Your presentations are always very informative, Mike. Now, I do have some questions here and also some visuals if that I'll put on the screen.
I should get out of share screen, right?
Yeah, so if you do that, you could probably go down, find the StreamYard, and there you go. Okay.
Okay.
Hey again, Mike. So excellent presentation,
thank you.
As always, very informative. And it really complements your previous presentation that you did with us, which I know because I just rewatched it last night in preparation for this. And so what I wanted to do for the audience sake, just to help make things even more understandable, is run through some of these arguments directly from those who you quoted in your presentation, Mike.
All right.
So, for example, here are some excerpts from an article on reasons from Dr. Hugh Ross.
Reasons to believe.
Yeah. So he points to exactly what you responded to in detail in your presentation, Mike. And so you left no stone unturned. So he looks to the 6 deep ice cores and 1 sediment core, says they now provide a clear and continuous record of Earth's history. The ice cores reveal hundreds of thousands of ice layers laid down on top of one another year by year.
Yeah.
Can you? Yeah, I was wondering if you could briefly touch on the assumptions there of them being laid down year by year, which therefore, if they're going to calculate it backwards, it's going to be hundreds of thousands of years, right?
Well, sure. But the annual layers, even in Greenland, peter out. They're good at the top, but they peter out as you get down in the ice core. And you start to pick up storms and substorm layers. So we have an explanation for those. But on Antarctica, East Antarctica, you don't have any annual layers. There's no way to come out with any annual layers whatsoever because the ice accumulation's too light. It's a polar desert on top of that ice sheet. So there aren't these annual layers. And even on Greenland, they only claim 110,000. And that claim is due to circular reasoning.
Right. You mentioned in your presentation, if I understood correctly, that this assumption of annual layers actually failed when tested.
Yes.
Okay. So it does amount to a lot of circular reasoning then, assuming the Milankovitch cycle is true as well, correct?
Yes, they assume the Milankovitch cycle. And so they're forced to redate the earlier version they put out from 85,000 at the bottom. And lo and behold, they got 25,000 more annual layers for 110,000 annual layers, just what the Milankovitch mechanism demanded.
How convenient.
And you can read this as plain as day in the Journal of Geophysical Research, that special issue I showed you from 1997. It was all on the GISP-2 and the GRIP ice cores.
You're finding the circular reasoning, the examples of circular reasoning and the many assumptions directly in the technical literature on this issue, aren't you, Mike?
Yes, right in the technical literature.
I love it. So when he says, I'm wondering here, just as a tree adds one new growth ring per year, is that also an assumption, an old Earth assumption, Mike?
That's how they compare it. That's how they put it over on people. They say it's just like counting the annual rings in a tree ring to determine the age of the tree. They use that analogy, but it doesn't work. And by the way, tree rings is also a bag of worms when you get to older ages, and for them it's only several thousand years.
Right.
I believe, I have not published on this yet, but I believe we can account for multiple annual tree rings in the bristlecone pines in the White Mountains, which is a lower mountain range east of the Sierras. One of these days I plan to do it. The reason I can account for it, this would be a research project in the future, is because early in the Ice Age, you had little seasonal contrast because you had warm oceans and you had all that volcanic aerosols. So you have cool summers, mild winters. And so you're not going to cause any seasonal oscillations in tree rings in the bristlecone pine on the White Mountains. Now, they're partly in the rain shadow of the Sierras, by the way, because they only go up to about 11,000 feet. The Sierras go up to 14,000. So with west to east flow, they got a partial rain shadow at the very top still. But I think I believe you can cause a tree ring based on wet, dry cycles. So if you don't have a seasonal contrast, you can have wet, dry cycles early in the Ice Age. And each one of these can possibly produce, this is all research, speculation on my part, can produce an annual ring, each wet, dry cycle. say you have monthly wet dry cycles, and these might produce 12 annual rings in 1 year. Early, we're talking about early in the Ice Age, which would be the oldest rings. So I think we can account for at least the bristlecone pine annual layers. But from their analogy, they're only talking about annual layers you see today. If I would put a core through a tree, a lot of trees, you'd see the annual layers and you get the growth. That's the analogy they use, but it doesn't work. It's an analogy that breaks down right away.
I'd be curious, what would be a good response if a critic were to say, well, wet and dry cycles only change the thickness, but not the actual number of rings?
Yeah, I'd have to think about that. It might depend on if you have in the dry cycle, you tend to get thinner ring. You have a kind of stopping or slowing, and they'd be like the fall would. So, yeah, if you get a real wet period, you can have a thicker ring, and then the dry cycle will cause it to stop or be like fall and winter. So I think even with I'd say it'd be more than just width of a ring, but I'm speculating. This is research I need to do, and maybe people in the audience will shoot it down.
Well, that's what it's all about, right? Putting forth a hypothesis,
Yes,
and then trying to refute that hypothesis. Let's see if it sticks, or if it's falsified. And so, Mike, what would we say as creationists in terms of the original created trees? When God created trees, did he create them, do you think, with multiple rings, or would it, how would we look at that, do you think?
Well, I've seen a lot of trees in the fossil record, a lot of vertical trees, like in the Cenozoic, and I believe very strongly that the Cenozoic is from the flood. And so you see a lot of vertical trees, which can be accounted for by the log mat, where they sink, some sink vertically. And I have a lot of evidence for this, in that in some cases, I've been able to see the bottom of these vertical trees, and there's no roots and no soil. I better take that back. In some cases, you do find the little bit of the roots, like in the Yellowstone so-called petrified forest. But in Theodore Roosevelt National Park, you see dozens of these vertical trees. Are about 6 feet tall. They flare out to the bottom, and then because it's a badland area, it's eroded, and you see what's underneath it. No soil, no trees. In other words, they didn't grow there. Secular scientists always assume that vertical trees grew there, but we think they dropped there during the flood. So I've shown other instances of that. See, I forgot where I was going with this. Remind me, please.
Yeah, no problem. I was asking about the original created trees. Do we believe that they may have had multiple rings to start off with, or would it start with?
Yes. Yeah, a lot of them do have rings. Mm-hmm. The ones I see in the fossil record, many of them do have rings, and sometimes very thick rings. For instance, the literature says that the early Cenozoic trees from Antarctica had rings up to 1 centimeter thick. Now, that's not going to grow in Antarctica, even in a warm climate.
Right.
It had to be transported there. Probably the largest vertical trees I've ever seen are in Colorado. What's that national monument? monument there. Oh, escapes my mind, but there are redwood trees 4 meters in diameter, and they have pretty thick rings. But the oldest tree is only about 700 years old. So there's plenty of rings, and even the largest trees we do have are well within the time between the creation and the flood. And of course, the flood ripped up all the vegetation.
Right.
A lot of logs floated, some dropped vertical. That's why we see vertical trees. Oh, by the way, the ones in this getting a little late. Can't think of the name in Colorado. 8,200 feet. Many people are familiar with it. You can see the bottom of these trees, and they don't have any roots either. So that's another sign that they didn't grow there.
That's great. Great points. You're doing great, Mike. Even the conventional literature will point out that contrary to the single ring per year idea or paradigm, alternating poor and favorable conditions in weather patterns can result in several rings forming in a single year. And they're even admitting that.
Yeah, some do. And some trees do more than others. And the bristlecone pine in the White Mountains, very thin rings. So it wouldn't be a stretch to say with the ideal climate early in the Ice Age with heavy precipitation, but you have dry and wet periods, you could form multiple rings per year, many rings per year. That's what I believe.
Yeah, very interesting.
Well, that's a research project in the future, and it's related to the Ice Age. See, a lot of things are related to the Ice Age, like the origin of caves.
Right.
Oh, that's why I get into these.
Which we did. We did a full show on the rapid formation of caves, Mike. I really appreciate how in-depth you are in this research. It seems like you really put the ice core dating challenge to bed. In terms of trees in general, just looking at the oldest living tree is not an issue for young Earth creation, because from my understanding, the Methuselah tree, isn't that dated somewhere between 4,000 and 5,000 years anyways, which would fit nicely with the flood.
Yes. That's on the White Mountains of California, the Methuselah tree. Yeah. It's only 4,000 to 5,000. And if some of those are multiple rings, it's well within the time of the post-flood time, which is about 4,500 years.
Yeah, that's an interesting point. So, okay, I appreciate that. That was our first slide here. So the tree ring dating has several built-in assumptions there. So he continues, Mike. He says 3 deep ice cores pulled from Greenland record the past 120,000 years, which you showed to be false in your presentation. 3 deep cores in Antarctica, Dome, Fuji, and so on and so forth allow researchers to look back. So even further than that, 340,000, 420,000, so up to about 800,000 years, respectively. What are, I guess, in a nutshell, someone were to bring up this excerpt, what would be a good way to point out the errors in it, Mike?
Well, it's the same. It's dated by deep sea cores, which are dated by assuming the Milankovitch mechanism.
Right.
And this is kind of old information. Dome Fuji, they've drilled that several times, that 340,000 year claim, based on 3 so-called ice age cycles, as now they got about 7. So it's dated about 700,000. Vostok's still the same, 420,000. And the 740 Dome C, they stretched that somehow to about 800,000 years, claiming 8 ice ages. So in a way, it's kind of dated. But regardless, it's all the same. There are no annual layers. Mm-hmm. It's dated by matching the oscillations, the wiggles, as I call them, from the ice core to the deep sea cores, which are matched by assuming the Milankovitch mechanisms. big circular reasoning networks. The same thing, and it'll be the same thing with 1.2 million years. They now claim for the Little Dome sea ice core, which I only saw news reports on it, and I'm anxious to see the data.
Very good, Mike. This is comprehensive, which is exactly what I wanted, because you still see, and I'm sure you do, especially in debates or on Facebook, you see critics of young Earth creation bringing up these exact same arguments over and over again. So I think it's good, it's beneficial that we show the critics and our fellow young Earth creationists that these have answers available. Yes. And so you touched on each one of these in this presentation, in your past presentation, Mike, in a thorough manner. And so he says, well, how do scientists confirm that these ice layers correspond to years of Earth's past history? And so he points to the so-called telltale markers. One of them, volcanic ash signatures.
Yes, I showed you those tie points in the new ice core from Greenland. I mean, Antarctica. Yeah, I see that.
And so that's not a telltale marker then, is it, Mike?
Yeah, they are. Krakatoa would be. I'm not sure about whether they can see the Vesuvius eruption in Antarctica. At least they might see it in Greenland. See, the thing is, volcanism that is in the mid-latitudes generally stays in that hemisphere. If it's a tropical one, it'll spread to both hemispheres. Now, a very large one in, say, the mid-latitudes of the southern hemisphere will spread to the northern hemisphere. So these telltale markers, like I said, the annual layers show up pretty good at the top.
Okay.
And so, like the Rice ice core, you do see the Krakatoa eruption of 1883, and that was in the tropics. I don't think you can find the Vesuvius one in Antarctica, but like I said, Greenland. But you see several others tie points. But notice it doesn't go past much past 2,000 years in the past ago. And like I showed, the Toba 73,000 years ago, which they have claimed for other ice cores, did not even show up in the tie points of the Rice ice core. So this thing doesn't say anything. It says that in the top, you do pick up these, and they're good dates, but it doesn't go very far down.
Oh, I get it. So you're saying it's a telltale marker in terms of the top.
The top.
Right? Yeah, the top, which we would agree with.
Yes.
Because it's only going back a couple thousand years anyways.
At the most. Probably barely 1,000 years. So, and sometimes one of the problems is that once you get past about 1,000 years, it's difficult to date these ash layers and to know which volcano it came from.
Good point.
So there's a lot of problems to extrapolate the nice recent volcanic eruptions of the past about 1,000 years. Krakatoa and Tambora 1815, Krakatoa 1883, are the main ones you see. Beyond Tambora, it gets sketchy quick. And so you can't make an argument for the rest of the ice core. You can only for the top.
That's really good stuff. Have you heard those that believe in an older Earth? They've argued that Mount Vesuvius, the eruption that wiped out Pompeii, I've heard them argue, and I think it was with argon to argon method. They say they've accurately dated that. And therefore, I think they use this as an example to say, hey, we know when this took place and the dates match. Have you heard that?
No, but I imagine they could. It's kind of young for argon or any radiometric dating method. It's carbon-14 would be a lot better dating method for that, because there's probably a lot of carbon that's preserved. So, but when you get that young with radiometric dating methods that date rocks, you're getting into some problem areas. I'm not sure you can date anything at 79 AD from potassium argon, argon, or rubidium strontium, or uranium lead, because the half-lives of these things are huge,
right?
Billions of years. So you're getting into hundreds of years. Yeah, you get into a lot more problems when you try to make these claims.
Yeah, it looks like cores were dated by potassium argon and argon to argon dating.
Okay. They make that claim. All right, I'd say that's speculative.
Yeah, I would agree. And typically it's a counter to, so I guess I'm curious what you think of this. We'll point out when it comes to dating methods, and I'm kind of getting ahead of myself because I wanted to ask you this a bit later, but I'm curious because he mentioned Vesuvius there. We'll point out that they've dated rocks of known age, newly formed rocks, and they've gotten incorrect dates of millions of years.
Yes.
And so we as creationists like to point out, okay, why are we going to believe or trust the dates that you're giving us of unknown rocks as in terms of when they were formed, when you can't even date rocks of known age correctly? And then they'll point to this as an example to say, no, we've done it correctly. Would that just be, let's just for sake of argument say it's true, would that just be an exception to the rule, Mike, do you think? Or
I think that I'm not sure how they wiggled out of that. I know they do. They try. It's still a good point, because there's a lot of dates on lava flows, or that we know are historical, or we've actually seen it flow. They give old ages. That's pretty solid. And so I would say the argument is still strong, and I don't understand how they can wiggle out of it, but they do wiggle out of these things by some extra hypothesis.
I've heard some say, well, don't you know, creationists, you can't date these rocks that were just formed like at Mount St. Helens, because you got to give them 100,000 or so years before you can accurately date them, or else you're going to get false ages. But isn't that assuming that the Earth is 100,000 years for us to have to wait anyways to date them?
Right. And what it's saying, though, is that this lava, see, their assumptions are a closed system, and like with potassium argon, you should start with 0 argon because it's a gas. But they always find argon, so they wiggle out of that and say, well, there's always some argon. And that's the issue. There's always some argon. You don't totally degas the argon. So what the older dates are saying on these recent lava flows is that there's way too many daughter products still there that didn't get taken out by heat or whatever. So that's the issue. But then it gets to say that, well, that makes the whole thing rather arbitrary, because you don't know how much, say, argon remained in there. They try to do an atmospheric correction on it, but I think that's speculative too, for the potassium argon method.
So it's basically showing that the assumption that there's no daughter element, that basically the clock is reset when these rocks solidify, is false. Because yes, there is daughter elements present for us to get any kind of date, really. Yeah,
you should think that the heat would totally degas the argon. That would be the first guess on that. But these old dates on young lava flows indicate that's false, which means, well, how much argon is is from the radioactive data, and how much is from left in the lava.
Mm-hmm.
And that's why, you know, when you get to unknown ages, those sorts of things tell me you really can't date a rock of unknown age by these methods.
And I think those are valid points.
Too many assumptions that are a problem. In fact, they use these main assumptions in radiometric dating to throw out what they consider bad dates. So I've seen this over and over, that how they throw out what are called bad dates because they violated one of their assumptions, like a closed system, or initial conditions are known, or a constant rate assumption. So those are the three main assumptions in radiometric dating. But there's a lot of other assumptions, and each dating method has its own unique set of assumptions.
That's right. Brian here, he's a fellow young earth creationist from Apologetics 101. He recently did a really good informative interview with Dr. Andrew Snelling, and they discussed this a little bit. So he put a comment up here, and he said, on the argon to argon dating, they claim on Mount Vesuvius that it corresponds with isochron plotting. Before I even continue reading this, I was reading a paper from Dr. Andrew Snelling just a few days ago where he was going over several discordant dates, even with isochron dating, because I see all the time in debates these guys, and they like to use isochron dating and look at these plots, the nice straight lines, and say, well, this works and this gets rid of those assumptions. But again, from what I'm seeing, and I'm sure you can speak to this too, that we're finding discordant dates even with isochron dating.
Yes.
So he continues here. He says, and when this is heated up, all of the excess argon is removed. So, Mike, maybe a couple things, if you wanted to speak to anything here, and then maybe go over a little bit why isochron dating doesn't really save the day, like many proponents of an old Earth would argue.
Well, yeah, you would think the heat would drive all the argon out, but they realized early on that there's always argon there. So they assumed an isotope ratio of argon between the atmosphere and the sample. And from that, which is based on assumptions, they came to an initial argon at the beginning. So regardless, that doesn't work. As far as isochron dating, that's beyond my pay grade. Andy Snelling has to answer that. I don't know enough about isochron dating, except I know there are exceptions to its accuracy with the straight line. And
right.
I can't go into the details of isochron dating.
Well, he's done a good job. I mean, yeah, it's definitely a technical issue, but from what I was reading and gathering from his, at least one paper I was reading, was even the isochron method has discordant dates, and the other methods, of course, have discordant dates, as we're describing here.
Yes, and he's the source. He has looked at this probably 100 times as much time as I have. I've learned a lot, but he knows a lot more. So if people want answers, go to Dr. Andrew Snelling's material.
Yeah, I guess you can find mixing lines and false isochrons. Andrew Snelling talks about.
Yeah, that's true.
And that's what's so important about being a team, coming together, being a community, is we all have our various skills and expertise. For example, anytime somebody brings up caves or ice cores or the Green River Formation, the Grand Canyon, I send them your stuff, Mike. If someone brings up isochron dating, here's some material from Dr. Andrew Snelling. So it's good that we can all come together and help the cause, right? We need the more researchers, the better, really.
Yes.
Okay, so I'm curious as to your thoughts now on this next point. And so I appreciate how thorough this is. I think this is going to be very helpful to people, including social media. So share this out, guys, as I still see these arguments circulating. So the next telltale marker, climatic cycles also allow for testing. As it turns out, these cycles caused by regular variations in the eccentricity or ellipticity of Earth's orbit and the tilt of Earth's orbit correspond perfectly, he says, with what's seen in those core layers. So what would is that true? They correspond perfectly, Mike?
No, not perfectly. Where does that come from?
Dr. Hugh Ross here in his article, Deep Core Tests.
Another indication of poor scholarship. That, first of all, they're not perfect. It's in their scheme, it's kind of a rough correlation. And like I said, there's almost zilch power in the 100,000 year cycle. The tilt has a lot more power, and but it's a 100,000 year cycle. That's the main cycle in all this. And they'll only use the tilt and the precession for more minor things, but not the major oscillations they think are from the Ice Age. The Ice Age repeats every 100,000 years, they claim, for the last million years. But before a million years, it was every 40,000 years, which just happens to match the tilt cycle. I wonder if there's some circular reasoning in there too. But they don't know why it would switch from 40,000 to 100,000 years. But anyway, that's a conundrum that they're still working on. They have all kinds of them, but this is just poor scholarship.
Because they are, especially those in the old Earth creation camp, Mike, they reject the worldwide flood and they argue it's a local flood to the world of the ungodly. We've addressed that many times. Yeah. But the point is, aren't they now rejecting a lot of the mechanisms and after effects of the global flood, like the warming of the oceans being just one of them, to explain what we see in terms of the Ice Age, as you've gone over in your presentations, Mike?
Yeah, they probably accept the secular view of the Ice Age with multiple Ice Ages. And they in rejecting the flood, you reject so many other things, and when you bring the flood back into Earth history, you can account for many anomalies, like even caves, the rapid formation of speleothems, and other phenomena, rapid ice age for ice cores. Yeah, it's the difference between taking the biblical record, the plain, clear-cut biblical record, versus adding man's interpretations from the universities and try to jam it into the Bible and use that to explain things. No wonder they get themselves in trouble and make statements like this.
Right. I completely agree. And in terms of explaining the Ice Age, the rapid formation of caves, as you pointed out, when it comes to limestone, do you believe that the rapid formation of a lot of the limestone could have occurred when the fountains of the Great Deep broke open? They could have released a lot of the necessary chemicals for that formation, do you think, Mike?
Yes, it's glad you asked that, because I'm currently this winter writing a book on the origin of caves, kind of like the talk I gave several years ago. And I'm supposed to make it understandable for middle schoolers. I have to give them a chemistry lesson even.
Right.
So I did look at the carbonate. 20 to 25% of the sedimentary rocks are carbonates. 20 to 25%. That's a lot.
Wow.
And we're not going to get that from fossils and that sort of. It has to come from the fountains of the Great Deep, from below the surface. Yes, plus other chemicals came from the fountains of the Great Deep. But yes, all that carbonate comes from that first. And then it has its own cement. I mean, calcite, which is limestone essentially, is a cement. So it could cement itself and harden. And then, so yes, I would definitely say it had to come from chemicals from the fountains of the Great Deep. The way it works is that it's dissolved in the water. And that, under the right conditions, it settles, it comes out of solution and is deposited. So carbonates are a chemical sedimentary rock. They make up 20 to 25% of all sedimentary rocks. And I might add that more than half of these carbonates are what's called dolomite, which is calcium magnesium carbonate, 50% calcium, 50% magnesium ions that bond with the carbonate. And the interesting thing about dolomite, which, like I said, is more than 50% of carbonates, is that it requires very hot water for dolomite to come out of the solution. Temperatures over 100 degrees centigrade are required. And we have huge dolomite formations, especially the older the ages, the more dolomite, which indicates to me the early flood had a lot of hot water. And some of these dolomite, as well as carbonate formations, that cover hundreds of thousands of square kilometers, and they can be hundreds of thousands of meters, hundreds of meters thick. I mean, we're talking about monstrous deposition. And dolomite being from hot water indicates that all another clue about the early flood being hot water. So yes, I do believe it all came from the fountains of the Great Deep, which would be hot by definition.
So much research, so little time, Mike. But I love the explanatory power of the flood model, rapid formation of all these things that skeptics of young Earth creation argue is a contradiction to young Earth creation, Mike.
Yeah, we're developing the flood model, and the more sophisticated it becomes, the more questions and challenges we'll be able to answer. So yes, sticking to the Bible. Amen. And then examining the data, like 1 Thessalonians 5:21, my theme verse for research. Examine everything carefully. Actually, there's only one carefully in it. I'm just emphasizing it. But hold fast to that which is good. You hold fast to the Bible as God's word. And I found when you do that and you look at the data, you can answer challenges. And I see a lot of evolutionary actualistic data because I keep up with about 50 earth science journals in the Montana State University Library. So I'm quite aware of challenges, many challenges. And we haven't answered many challenges because no one's actually had time to research it. We don't have a lot of researchers in earth sciences.
It makes it more fun, in my opinion, to be a young Earth creationist, having these challenges and therefore these research projects. If we had all the answers, then there'd be nothing to study or
it'd be really dull, wouldn't it?
Yeah.
In science would be dull.
And it's always exciting when you go into a challenge, scripture first, as you've pointed to, Mike. We go and we prayerfully consider these things. And it's always exciting when you come up with an answer. I'm curious, this is a little bit off of what we're looking at here, but in terms of the challenges you've looked at and you've offered answers for, what are a couple of your favorite challenges that you've looked into, researched, and come away with a good answer?
Well, I would say one of the biggest challenges that was given to us is how do you account for dinosaur tracks, dinosaur eggs,
right,
and bone beds that have carnivorous dinosaur teeth in it, indicating they were scavenged. How can you explain that early in the flood? So that ended up with the beds model, which I suppose I've talked about that on this program already, have I?
You have. You've given a whole thorough presentation on it.
I thought so. They're called the beds model. Caves are a big challenge. That's why I've gone into those. The Ice Age itself is a challenge. By the way, I might add that when I'm doing research on a challenge, I gather as much of the observational data as possible. And most of the time, I find that first of all, it's a challenge to the conventional scientists too. They really can't explain this data either. But a person wouldn't know, because a lot of times in a university classroom or reading a book on the subject, you wouldn't get into it. They don't get into it. And so, or they'll add a hypothesis saying, oh, this will explain it, when it's just a speculation. So that's what I discover, first of all. Secondly, in about 50% of the cases, I can find a reasonable solution within young Earth creationism. 50% of the time I can. About that, I haven't counted it, but that's kind of off the top of my head. So that's what I find when I look at challenges.
I find the same thing. I spend a lot of my time in the world of genetics. And when I'm looking into a lot of these topics related to endogenous retroviruses, chromosome 2 fusion, and so on, I'll find the best answers or problems directly in their own literature, and especially in their lectures, because you won't see internet apologists or critics of young Earth creation oftentimes discussing the problems or challenges with their model. You got to go deep into their literature or deep into their lectures to find your pieces of gold.
Yes, deep in the literature. And that's why I write those perspective articles for the Journal of Creation, because I find these, but I do not have time to do a full paper on them. So the perspective articles is a 1 to 3 page announcement of, hey, this great data, here it is, so forth. And hopefully someone else can run with it. Maybe I can run with it if I have time, but I have so many irons in the fire and research projects, I don't have time to do that.
We could just retire from needing to sleep, and that'll give us another 7 to 8 hours every day, Mike, for research.
Yeah.
Okay. So the next point here, you're doing an excellent job, Mike. Appreciate this. So we just did climatic cycles. And here's the other big one, as we know, which we kind of touched on. Hugh Ross and other proponents of old Earth creation, or just naturalistic evolutionists, they'll say researchers have performed radiometric dating of minerals embedded in the ice to make sure their age corresponds with their annual layer. And according to him and others, in each case it does. So they have these different things they'll look at to corroborate their argument or dates with ice cores. What would be a good response to this, Mike?
They can't date with radiometric. They can't date an ice core with radiometric dating. I've heard of attempts, but I never run into it anymore. I have no idea where he picked that up. And how could radiometric dating be so fine to pick out an annual layer of 1 year?
Right. Yeah, that's a good point.
Half-lives are billions of years, and it doesn't make any sense on itself. And the fact that he says it does, this is just beyond poor scholarship.
It seems like it's more of an assertion. Like, well, we'll perform radiometric dating of these minerals embedded in the ice, and it just so turns out that their age corresponds with their annual layer. And in each, and that would be pretty precise, like you said, Mike, to correspond with it. That's every year, according to them.
Yeah, the minerals would be in the dust, and that's pretty fine. No, it's just not true at all.
Mike, what are your thoughts on? So in this article, he goes into one or two of how young Earth creationists respond.
Yeah.
So he goes into the burial of the lost squadron.
Yeah.
But he says intrusions into the layers by localized forces and events does not invalidate them, as in the dates they get from the ice core dating. What are your thoughts overall on the lost squadron? And then his point about the intrusions.
Yeah, he had a.
Because some creationists would say, well, the lost squadron was under 250 feet of ice.
Yes, true.
And snow in only 50 years. So basically.
Yeah. What that is all about is that they didn't know about this. Was a local bullseye of heavy precipitation in southeast Greenland. About 1.5 to 2 meters of ice accumulation a year. And they didn't know about it until the lost squadron. And, you know, they should have had some idea because it's close to the semi-permanent Icelandic low just to the southeast. So it should be an area of heavy precipitation. In fact, I happened to just pass through Middleborough, Kentucky, when they were just finishing the putting together of Glacial Girl that they brought up in pieces. That's the airplane they brought up. And I asked the supervisor, how deep did they think the ice was before they went out there? And he said about 30 feet. So, but no, it's a local bullseye of heavy precipitation. Now, we can't use that to say that the ice occurred rapidly to account for except when the ice sheet was low, that would apply, because right now at the top of the Greenland ice sheet, it's only about 25 centimeters of ice a year, much less. It's an indication of what we can get, or when the ice sheet is still building, you're going to get meters per year. And this is close. The southeast Greenland is close to the Icelandic low, and that's pretty cold water. So you don't get a lot of evaporation from it, but you still get 1.5 to 2 meters of ice accumulate a year. That should say something, especially if you have all of Greenland that's not glaciated yet, and yet it's surrounded by warm water, which would evaporate much more water vapor than in the Icelandic low area. So it gives an indication how fast it could build up.
Right.
So that's what it tells us. We can't say that that's the amount of precipitation for all Greenland. Now that'd be going too far. But it's just
is it basically just an analog to how quickly it could build up? Not that this applies universally.
Yes, exactly. It's an analog of when it was low altitude, like southeast Greenland's low altitude, and with no ice, and it's just starting to build. This gives you an indication that, hey, in our model that starts from 0, we can get meters per year of ice accumulation for quite a while during the Ice Age. So it can be used as an analog for our claims of meters per year of accumulation early in the Ice Age, especially.
Right, because in your presentation, you said at the end of the flood, we as creationists, according to our model, we'd start with 0 ice, and then the ice would build up throughout the Ice Age that lasted roughly 700 years.
Yep.
And so it'd build up rapidly.
Yeah. Yeah.
Okay. Well, we dealt with those points, and this is what I love is from what I've seen in your 2 presentations here, Mike, you've addressed their major points on this issue, but I haven't really seen a good counter or rebuttal to the model that you're presenting. Have you, Mike? Have you
No,
seen?
I haven't.
And I look, and I haven't seen anything
I
worthwhile.
wish the skeptics like Hugh Ross, biologist people would actually read and analyze my material and other creation scientists' technical material.
Right.
The fact that they don't, and I've read their books, and they hardly refer to any of our material. If they refer to any of our material, it's Whitcomb and Morris's Genesis Flood, which is pretty old stuff.
Mm-hmm.
Me, this is a sign of poor scholarship.
Yes.
Because if you want to rebut an argument, you need to find out what those people are saying first. They need to find out what we say and first before they counter it. Obviously they don't. And it looks like they make up stuff.
Yeah. Or attack they're not engaging our stronger points. They're attacking older points, or maybe points that aren't as strong, weaker points, but they're not engaging the best that our side has to offer, like what you've offered here on the Ice Age.
Yeah.
But then they'll tell their audience that, well, or their readers, well, ice core dating refutes a young Earth, but then they're not engaging our best points like you've offered in these lectures. So, Mike, they're more general argument, and we touched on dating methods a little bit earlier, obviously, and some of the problems and assumptions and issues with it. But they'll say, well, even in light of some of the contradictions to an old Earth, they'll ask the question, but why creationists? When we date lower rocks, they always come out older than rocks at the top. There seems to be this progression of older rocks to rocks that are younger. And so they'll say this speaks to the antiquity of the Earth. In your opinion, what's a good response or a way to engage that?
Well, we know that the deeper rocks are older than the rocks on top, unless you have an overthrust. And if you use their dating methods in a relative sense, which many creation scientists do, and I do sometimes, the older rocks will give you millions of years. And I think we answered that of why you get such old dates from the RATE project. And that's accelerated radiometric decay sometime in the past 6,000 years. That is very solid evidence. Same with carbon-14 and diamonds.
Right.
Those are the two ones I use a lot from the RATE project. So we believe in this accelerated radiometric decay. We can't answer when precisely. Some think it's in the creation, some think it's in the flood, some think it's both. It's unknown, but usually the flood, practically all of us believe that some component of it occurred during the flood. So if you had accelerated radiometric decay in the flood, the older rocks would give you millions of years. And as you get to younger rocks, it would give you less millions of years. So yeah, that's how we'd account for millions of years. And I think I have talked about that. I've had something on dating, haven't I?
We've talked a lot about dating methods, but I don't think we've dedicated an entire show to it yet. So that could be a teaser into an upcoming show just on dating methods.
I have a number of aspects besides radiometric dating on old ages, for instance, processes that are claimed to occur, take too long to occur, like oil and coal formation. But you've had other creation scientists on that have addressed these dating methods, have you not?
Absolutely. It's funny. We've addressed them over and over again, but the critics keep bringing up the same arguments over and over again as if they weren't addressed. Like, for example, on the C14 in diamonds, Mike, that shouldn't be there. I mean, diamonds are the hardest substance on Earth. Supposedly they're billions of years old, yet we find detectable levels of radiocarbon. I've got a whole chart of instances where you have, right from the radiocarbon literature, right from their journals, many examples of C14 where they shouldn't be. So this isn't even just I've heard Dr. John Baumgartner point out that, yeah, he's seen that. He tested it, found the same thing, but also found it in diamonds. And what they'll say, Mike, they'll say it's either due to environmental contamination or contamination in the lab.
Yes, for instance, coal. Now that's what they'll claim for coal. Hundreds of times, by the way.
But since we're getting pretty consistent, I don't want to say dates because we're not really dating the coal, the fossils, the diamonds, but we're consistently finding carbon-14 in basically anything with carbon in it.
Yes.
Wouldn't this appeal to environmental contamination seems like a rescue device? I'm wondering what your opinion is, because then you would need equal amounts of contamination in all these different samples all throughout the geological rock strata. That seems far-fetched to me.
Yeah, like we've emphasized coal dated 15 million to 350 million years. And we and secular scientists have always found carbon-14 in it. And they've always claimed it's contamination of one sort or another. But, when someone's taking a sample of coal, they don't take a sample through a crack where you can't have young carbon coming down through the crack and being absorbed. No, they'll get as pure as they can. So it's a rescuing device. And that's why I think the carbon-14 in diamonds is so valuable, because it's very difficult. In fact, I've read some of their attempts. Very difficult to explain contamination of a diamond. So I think that carbon-14 in diamonds is an extremely solid argument that the Earth is much younger than they claim. And I don't think their attempts to refute it hold any water.
No, I completely agree with you, because what I see, and I wonder if you agree with this, I see a lot of lines of evidence or arguments being employed from both sides, the evolution creation models, that are largely agnostic to the debate, where both sides, they have a rescue device. The rescue device, okay, it sounds decent, let's say, for the evolution side, or points of evidence where both sides can explain. But when it comes to the C14 in diamonds, I've yet to see even a good rescue device from the evolution side. So this seems to be, rather than agnostic, this looks to me as if it's discriminating evidence where only the young Earth model can account for it. Yeah,
it's ignoring the data and not following the data.
More recently, I've seen critics now bringing up a paper where they say, so I'll put it up on the screen. It's a paper by Taylor and Southen, where they say that they've demonstrated why the radiocarbon would be contamination. But lo and behold, and to no surprise, Dr. John Baumgartner gave a very thorough response to that paper years and years ago, right here, 2007, he responded.
Yeah.
So they're putting forth this paper as if it's some great answer, but yet I think that goes to show what you were saying earlier, Mike. They're not really up to date on what we're saying, are they?
No, they aren't. They're not. So they need to be updated before they even open their mouth or write anything, because they're not. They make all kinds of crazy statements like the ones we quoted from Hugh Ross.
Right.
So it's just crazy statements even.
And that's their leaders in their position.
Yes.
Here's a question from the audience, from a critic. Again, we always appreciate our critics and skeptics. We hope to plant seeds. Yeah, we've had great audience engagement as always. These are, I get it, they're technical topics, but they're important because we do want to leave no stone unturned. We want to have an answer to every challenge and objection that's thrown at us. So he says, please explain. So ancient coral reefs in general, they'll say there's not enough time to account for them.
Yeah,
but he's got a specific one in here in Utah. I'm not sure if you're familiar with this one, 8,000 feet elevation. So I guess in general, what's a good response from us young Earth creationists to coral reef formation?
Well, number one, you got to prove it's a real coral reef. The ones in the rocks are practically always different than the ones we see today. A lot of times it's just a carbonate bank with some fossils in it. And a lot of times you don't find corals. You find, like in the Capitan so-called reef in New Mexico, the reefal organisms are sponges and algae. So is that much of a reef? Yeah. So we would, number one, question the reality of a reef in the sedimentary rocks. Number two, it doesn't matter if it's at 8,000 feet or not, because we believe that as the floodwaters drained off the continents and the mountains rose up in relative to the ocean basin sinking. So everything rose up out of the floodwaters. So all the high mountains you see today came up out of the floodwaters. So yeah, any coral bank, any carbonate bank, which I believe all these so-called reefs really are, they can be uplifted a tremendous amount. In fact, on top of Mount Everest, there's a layer of limestone with crinoids and brachiopod fossils, which I suppose some people can claim would be a reefal material. So the elevation makes no difference within the creation model.
Very good, Mike. So here's the next one. What about valleys that formed through glacial erosion, which is said to be a very slow process? And I think this is directly based on the post-flood ice age, I think. So yeah, I guess, what are your thoughts, Mike?
Well, first of all, it's well known that the valley came first. There was already a valley there. And the glacial erosion just modifies the shape of the valley from a general V shape to a general U shape. But there are exceptions to that. I've seen glaciated valleys that are V shaped still. So, yeah, it can occur pretty fast because you already have a valley. Just fill it up with ice and move it along, and it does some eroding along the sides and the bottom, and scratches the bedrock. So ice doesn't really do a tremendous amount of erosion. So that's all I have to say about that.
No, that's good. Here's a big one that I have here. I've seen this. I think I've seen this one put forth on Talk Origins. They're a big anti-young Earth creation website.
Yeah.
And so they'll say, how does a worldwide flood account for angular unconformities, where one set of layers of sediments have been extensively modified, for example, tilted, and eroded before a second set of layers were deposited on top? Does this require 2 periods of deposition? And therefore, so then they'll say lots of time basically to allow for deposition, erosion, and weathering. What's a good response to that, Mike?
Yeah, angular unconformities. Yeah, it probably would account for 2 periods of deposition. And when you look at the deposition of some of these layers, I read about sedimentary layers all the time, and often they're over 1,000 meters thick. So early in the flood, especially, you had huge sedimentation, huge erosion, huge deformation. So you can lay down a layer, and you can mostly solidify it because lithification can occur pretty fast. And you can push it up, shear it off, and lay another layer on it for an angular unconformity, all early in the flood, rapidly with powerful forces of the flood. And that's why I especially believe in that impacts, meteorite and comet impacts, especially occurred early in the flood, because they would cause all these effects and more. So, yes, we can account for it in our model.
Right. And it's one of your first presentations you gave with us, Mike, which was an excellent presentation, was the receding floodwaters.
Yeah. Okay.
And I think you covered a lot of that in there, if I remember correctly.
No, that'd be more towards the recessional stage of the flood, where it erodes the top of the sedimentary rocks. And by the way, we made a good estimate on how much erosion occurred during the recessional stage, and it averages 1,900 meters, almost 2,000 meters average erosion of the top of the sedimentary layers on the continents as they were coming up out of the floodwaters, waters running off. That'd be different than forming angular unconformities, because that'd be more early flood, which I'm doing a lot more research on the early flood, by the way. So, and I have lots of stuff I need to write up.
So basically, okay, so I think I understand. So during the worldwide flood, in the early stages of the flood, to explain these angular unconformities, you'd have waves of deposition and waves of erosion going on where they're laid down rapidly, basically.
Yes, and deformation, where you push it up, then you'd shear it off by a fast current and deposit more sediment. So you can have sediment like that with flat sediment on top, like you have in Scotland there, that James Hutton made a big deal out of.
Well, that's great, Mike. As I've said, you're an encyclopedia worth of information, brother. So that's good. So this next one, I see this one brought up in debates frequently, where the critic, they'll challenge the young Earth creationists, and typically this is an atheist or an evolutionist. So, because I understand within the creationist community, we have differences in opinion on where the flood boundary is, where it's located. And we've done a whole series on that, Mike. And I would recommend people check. Actually, on my website, if you go to standfortruthministries.com to the audience, search flood boundaries. We got a ton of content on there from you, Mike. But those that reject a worldwide flood, they'll challenge us. They'll say, well, if a global flood occurred, there should be a distinct, widespread layer of sediment across the planet. But then they assert that no such layer exists. Is that a straw man? Or
yes, straw man right away, because you'd expect the flood sediment to deposit over a pretty wide area, but not globally. And a lot of sedimentary layers are laid down over continents, like the Tepete sandstone over half the continent of North America, and other formations like the Red Wall Formation in Grand Canyon. You can trace that limestone up over much of western U.S. And other layers, which you can go to Grand Canyon to that's a good road cut, quote unquote, that shows the layers, which you can show extend over much of the region. Like the Morrison Formation covers much of western United States, Rocky Mountain areas, and the High Plains. Same with the Pierre Shale. So these are big. These things are big. And if we use uniformitarianism, even in a hurricane, they shouldn't be able to explain, even though sure they try, huge deposits over maybe a million square kilometers and maybe 1,000 meters or more thick. I mean, these defy uniformitarianism, but this is typical of the sedimentary rocks on the Earth.
We spend a lot of time answering challenges, which I think is important, Mike, because I love to refute evolution in an old Earth, and it's pretty easy to do with a lot of these points, but we also want to model build. We also want to answer challenges, which oftentimes is more fun in a way. And so do you find that a lot of the points like you're making that just defy uniformitarian processes, do you think these are challenges that largely go unaddressed by those in the secular world?
Yes, I do. Such huge formations are practically ignored, the size of them. And speaking of it, I'm in with other creation scientists in what's called the Flood Sediment Research Projects, which we are determining what the sediments, thicknesses, and areas, and trying to figure out where it came from, how it's transported, how it's deposited in the flood. So anyway, that's a research project we've been doing for about 5 years. We got some fantastic data out. I don't know if you've had, I think I've given one talk on that here, haven't I?
Yeah, I think you titled that one Incredible Advancements in the Flood, something like that. I think that might have, or that could have been a different
that's right. Yeah. I can't remember exactly what I've talked about on your show.
You've done a lot.
But we got new information, and we're getting new information all the time.
Yeah, that's great. I love it. So, okay, here, as always, Mike, appreciate the answers. When did granite batholiths form? So I guess a technical definition of that would be a large mass of igneous rock made of granite that forms deep within the Earth's crust. So I guess basically, when did those form according to the creation model, Mike?
Well, us creationists think that the granites of the upper crust were created rocks, upper crust being created. It's possible some of these huge granite batholiths were those created rocks being pushed up in a generally solid or a semi-plastic state. Some creationists believe that granite formed during the flood, solidified rapidly, and was either eroded down to that level or pushed up. So we say that, well, they formed during the flood. The batholiths themselves, the granite itself, maybe pre-flood or formed during the flood. So there's different ideas on that. But in general, the batholiths themselves are the big upward intrusions. They would be from the flood as the mountains rose. A lot of these mountains are granitic mountains, and they pushed up during the recessional stage of the flood.
The granites that we might say are created, Mike, do those in the conventional camp, do they have good explanations for the origin of those granites?
No, they try to do it by subduction. Generally, the subduction mechanism, which I think has some problems, generally forms lava. Island arc stuff is different types of lavas, but not plutonic igneous rocks like granites and all the different names for granite type rocks. There's all kinds of granite, diorite, quartz monzonite, all kinds of names for them. So yeah, I haven't really read a lot in that research, but I've done enough to know that they have problems accounting for all that granite. But they do it by subduction somehow, and I don't know how, because like I said, subduction supposedly forms island arcs, which are volcanic basalts, andesites, especially andesites, dacites. So yeah, I think they have problems with the formation of the upper crust rocks.
Therefore, would that be good supporting evidence for our model that these upper rock granites, is that what you're saying, were created, since they lack good explanations for their origin?
Yeah, if it's difficult to form it naturally, well, God created the earth, and so he would create continents, and so by definition, the granites of the upper crustal rocks that form the continents would be creation week rocks.
Well said. Yeah, that's good. It's kind of like if we were to go into DNA, right? They lack a good explanation for the origin of DNA and all of its complexity. And so we would say your lack of an explanation is good supporting evidence that DNA was created. And these granites, there's good evidence they were created, which would make sense. We understand if creation's true, then there'd have to be created aspects to it. Mike, can a single worldwide flood account for such extensively detailed layering? What's funny is I asked AI, just out of curiosity, Mike, have some fun with AI. Is there evidence for a worldwide flood? And AI said no, because a worldwide flood cannot account for such extensively detailed layering. So now we're refuting AI. What's a good response, Mike?
Well, you should ask AI of what mechanisms do we know of that can form layers?
Yeah, that'd be.
They'll probably give you about 5 to 10. And one major one that they might not know of. See, AI only gets information that's already been put in a computer.
That's right. Yeah.
Big databases. And one mechanism that they probably you can't get is that in the ocean right now, there's what's called internal waves. They're kind of like waves on a surface, but they're waves on a discontinuity. Maybe it's due to a different density from salt or temperature, and oscillations cause waves. And then as currents go by a barrier, they always cause waves downstream. And these waves can form layering. They can erode and then deposit each cycle. So I've written about this. It's in the perspective articles in creation.com or Journal of Creation. And right now there are huge amount of internal waves in the current oceans. And during the flood, I mean, with all these strong currents and hitting barriers, you'd have a huge amount of wave action. And so these waves can form layers. So I think internal waves are a good explanation for many of the layers.
That's a good explanation. I found if you ask AI the right question, Mike, they'll answer it in a way that supports creation. So for example, I've asked AI in research on transitional fossils, I'll say, why are there so few transitional fossils if evolution is true? And the answer is there are so few so they admit that, yeah, there's little evidence for that. And you can ask a variation of questions on their favorite arguments and see that, yeah, they are lacking.
Ask him that question. How many ways can you layer sediments? Ask that question.
Yeah, I will. That'll be good.
Email me back the answer.
Okay, that's great. You got to be strategic in the way you ask it, and you'll get good evidence for creation in a global flood. And I've really been enjoying that.
I should use it. I should start using it because I can probably. It'd be a first guess. I realize that there can be big mistakes in AI, but it'd be a first guess on a problem. So I should use it more.
Yeah, it's good when doing research. I've found it really helpful. I've been doing research on the evolutionary story related to the hominin fossil record and why there's so few hominins actually found, like Homo erectus.
Yeah.
And so I asked it, why are there so few Homo erectus fossils if evolution's true? And its response is, there are very few Homo erectus fossils, and the reasons why are, and largely rescue devices.
Yeah.
But I like that they're honest, Mike. AI admits to their challenges, brother.
Mm-hmm.
So, okay, here's a big one. You've written a ton on migration post-flood.
Yeah.
And so Alex is wondering, how did kangaroos get to Australia from the Ark? But can I ask you a double question?
Yeah.
It's based on the same thing. Because I actually read an article, and again, I think it was from Talk Origins, if I remember. It could have been another one of these anti-young earth creation websites, but they'll go a step backwards and say, well, wait a minute, how did the kangaroos get to the Ark? And then how from the ark did they get back to Australia? But correct me if I'm wrong, doesn't the Bible say that basically God sent the animals to the ark?
Yes, God sent the animals, and they could have been living close by where the ark was built. So that's a
that one's easy. It's more so how did they get back? It would be the bigger
that's
question.
the real challenge.
Yeah.
And well, I believe they migrated pretty fast to the Indian Ocean. And I hear there is a petrograph of what looks like a kangaroo found in India a few years ago. You can read about that probably on creation.com. And I believe that log mats were floating around for quite a while after the flood. And so animals, as a log mat beaches, animals would sometimes migrate on them, and then maybe a high tide or a storm would lift the log mat. Now, these log mats would be huge. They'd probably be 100 up to 100, around 100 square kilometers, and they might be 10 meters thick of jammed up vegetation. And there might be, you can have green plants growing on them even, because I got pictures of logs in the water where green plants are growing from them. And so this could be a total different ecosystem. And kangaroos or other animals could get on these log mats and get transported long distances. That's how I think the marsupials got to Australia. And all the marsupial fossils are post-flood, I believe, even though they date them as old as late Oligocene. But I think that's due to circular reasoning, because when they first found all those marsupial fossils, they dated them in the Pleistocene. In other words, Ice Age. You think post-flood, well, yeah, that makes sense. But then they saw what they thought were primitive features. And they said it has to be older if it's primitive, and therefore by what's called the stage of evolution. Yeah, stage of evolution was a main dating method used for the marsupials. And it has been used, but I think in a more minor sense for North America and South America. But anyway, stage of evolution. Say, oh, we have to put this in the Pliocene. Oh, but here's something even more primitive. It goes in the Miocene. Oh, here's one that's even more so late Oligocene. That's how they dated. And you could probably get that resource on creation.com, because I've written a paper on that. So that's how I think they got there, and they're post-flood, and they're just dated by a crazy stage of evolution, because they didn't hardly have any radiometric dating methods to go on when they first dated these things. So it's just based on stage of evolution, which is just circular reasoning. What is a primitive feature?
Right. Yeah, that's exactly what I was going to ask you.
Advanced feature. It's all arbitrary.
Yeah, so, when they talk about basal or primitive or derived,
yeah,
they're assuming, I think they would say a primitive feature would be like on mammals, body hair, because all primates have body hair, which means the earliest ancestors would have had body hair. So it's primitive, I think. So, I mean, that's all assuming evolution. That's all assuming body hair even evolved in the first place, and that we're looking at evolutionary succession. So when they say primitive marsupials, what do they really mean by that? Because they would say Homo erectus is a primitive human.
I know. Yeah.
But based on what? I mean, it looks fully human to me.
Yeah, right. His brain size is almost the size of modern man, and Neanderthals are even a little larger than modern man. So they have unique skull features. And I think that the top expert on fossil man among creation scientists is Peter Line from Australia.
Yes. Yeah. He's great. We did a nearly 10-hour series together addressing just all their favorite icons.
Oh, good.
Australopithecus, Afarensis, Neanderthals, Heidelbergensis. So,
oh, you've been on it.
He's a wealth of information on the hominin fossil record, like you're a wealth of information on the flood, brother. Okay, well, we're going to start to wrap it up, but I did want to ask, based on what you're saying, if as a creationist we choose a lower flood boundary, in light of what you're saying, we're saying that the kangaroos or a lot of the marsupials in Australia are post-flood. But we would also have mammals in the flood too. But if we add a lower flood boundary, would we be forced to say that there's really no mammals in the flood rocks and they're all post-flood?
There are some mammals in the flood rocks and the Mesozoic, but if the Cenozoic post-flood, you're going to have to say that hardly any mammals were buried in the flood.
Yeah.
But millions and tens of millions of them were buried after the flood and fossilized after the flood. What?
Yeah.
And then if you look at the details, you have various mammals that suddenly evolve and then they go extinct, like the Brontothere, which is a kind of a weird rhinoceros. He came along in the bottom of the Eocene and disappeared at the top. Is this a worldwide sequence for this post-flood? So it runs into a huge amount of conundrums if you believe in a low flood post-flood body. This is one of 35 criterion I have that it's an upper Cenozoic, especially in the Pleistocene, to me the post-flood. But even parts of the Pleistocene, I think, are from the flood.
Yeah, it's a good helpful response. So would they have to say, well, most of obviously they would agree, as in those that have a difference in opinion on flood boundaries. If you were to hold to a lower flood boundary, would you have to say that most mammals, as in there's only a few mammal fossils from the flood and most are post-flood? Yeah. Would you have to say that possibly they existed in a community? Because we would explain a lot of the fossils, the ordering of the fossils, due to burial by ecosystems and communities.
Yes.
So would they say that mammals simply existed in a community, maybe at a higher elevation, that just simply did not get fossilized? Maybe because of where they lived?
Okay, if you have the KPG boundary, mammals have to originate from the ark, starting with 2. And they have to mushroom, spread all over the world, even to North America, when you have all these huge catastrophes going. The history of the Cenozoic is huge catastrophes occurred.
Yeah.
So how are you going to be able to form develop tens of millions of, hundreds of millions of mammals, spread them globally, bury them, sometimes buried thousands of meters deep, fossilize them all after the flood? So yeah, that's I think a pretty powerful argument that the flood boundary is a lot higher, and that these mammals of the Cenozoic were buried in the flood.
And the flood was a geological catastrophe.
Yes.
And so when we look to geology rather than paleontology, then we come up with an upper flood boundary. I think it has more explanatory power in terms of the geological features that we find, right, Mike?
Oh, yeah, by far. I said I have 35 criteria, and you can look at my website where I flesh them out, or on creation.com. Those creation scientists that believe in a boundary near the KPG, the Cretaceous Paleogene or Paleocene, mostly do it because of fossils. And they have a pretty strong argument, but I've been I spent a lot of time looking at that argument, and I think that I've come to the conclusion that many of the Cenozoic fossils can look close to modern genera, can look close, but genera and species and all that classification I also found is kind of a bag of worms too, where there's a couple dozen definitions of species. Anyway, and right now they're arguing about what's the higher level classification of dinosaurs at the order level. And they're saying that this HIP criterion is rather arbitrary. So there's a lot of controversy there. But so I've come to the conclusion that you're going to have some mammals that are from the flood that are fairly similar and maybe even identical. I haven't taken it that far with ones we see today. I'm coming to that conclusion.
Well, that's good. So those in the lower flood boundary group, I guess, they have more geology related challenges. We in the higher flood boundary, we have more paleontological related challenges, but you're saying we have some pretty decent answers currently. We're working on it, but currently we have some okay answers in explaining the paleontology, Mike.
Yes, and I've spent hundreds of hours looking at that stuff, and that's the conclusion I've come to, is that many of these, especially mammals, that some of them are close. Like I believe you can have what's called a mastodon from the flood and a mastodon in the ice age. Now, a lot of times the mastodons from the flood are different than those in the ice age. They're not exactly the same. They might be put in the same genera, but they could be still very different. Like you have the American mastodon in the U.S., but then you have a mastodon that has 4 tusks. They redefined it as a gomphothere there, which is essentially a new definition of certain mastodons. But so this is what I find. And it could be you find mammoths that are from the flood, but they'd be different than the woolly mammoth I'd expect. And so these are possible. I wouldn't think you'd have very many of these. You can have the fossil record has a lot of elephant kinds. And so in those kinds, some of them are close to mammoth and mastodons that are from the ice age. So I've come to that conclusion looking at their data, hundreds of hours of looking at. But on the contrary, the paleontologists don't look at the geological arguments that Tim Clary and I have advanced over the years, the 35 criterion, like Cenozoic coal. You have a lot of coal in the Cenozoic, clear to the late Cenozoic. And I can't see any way that can be formed post-flood. So that would say the boundary is way up there. So that's one argument. I mean, there's 35 of those. And I've talked to them, and they don't really want to go into it, which to me, their whole argument is from a weak point of view if they haven't examined Clary and my geological argument. Some of our arguments are from paleontology too, by the way, from organic, like the one you mentioned about the mammals.
Right.
That's one of
whales. Whales is a big one.
Yeah, that'd be part of the mammal argument. So
yeah, I've found your presentations. You've done 3 here on the channel. I think 3, one on the post-flood, pre-flood, and then we did like an answering the critics one. And also so heavy material there. And also Tim Clary, he's given a recent presentation on where the flood boundary is on another channel, Logos Ministries, I think it was. And so I found them all to be very convincing, Mike, especially in terms of the geologic evidence. And so I was going to ask you another question, but I guess it's getting late here too. And now I forgot. Yeah, so Mike, maybe that's a good time to wrap things up. Very comprehensive as always, Mike. Time flies by. I wanted this to be one of those go-to videos for people on ice cores and the ice age. And I think that's exactly what this was. I'm glad we were able to address some of the critics too in detail, as in pull up Hugh Ross's article, go through it line by line as you did. And so to you in the audience, the next time a critic or a skeptic of young Earth creation brings up ice cores or what they say are a number of ice ages in the past refuting young Earth creation, send them this video. Tell them it's thorough and challenge them to examine it in a sophisticated way. So Mike, appreciate you doing this. I know how busy you are with research. And so I know I also speak for the audience, brother. We really appreciate the time that you give us here on Standing for Truth. I want to hand it to you if you had any final words, final thoughts, just anything you might want to leave us here with tonight as we wrap things up.
Yes, I do want to have a last word for the skeptics. I'm glad you're listening to this. Just think of it this way. The Bible was written over 1,600 years by, 40 authors? And yet it can be shown to be extremely consistent from an objective point of view. Now, we would say it's totally consistent. And we can answer challenges once we look at the data, stick to the Bible. Wouldn't this tell you that maybe you should take the Bible more seriously as God's communication to us, and take the spiritual truths of what Jesus did more seriously? So I ask you to think about that. And that's what I'd like to leave you with.
Amen. Beautiful final words. Nothing more important than where we're going to spend eternity.
Yes.
And what the truth is, Mike. So that's why we do this. It's not always about winning arguments. It's about winning souls, winning you guys over to the truth. So for those that love Mike and what you're doing here, check out standfortruthministries.com, Michael J. Oard. I need to add this one there now. Also creation.com. And you have a website too, Mike, where you got some good stuff that I've got linked in the description box for people to see.
Yeah, I do.
Oh, I think you got a lot of stuff on the flood boundary. I remember taking a deep dive there. You got a whole bunch of stuff, I think,
on flood boundary. On the flood boundary, and one on the recessional stage of the flood, all in color pictures. And they're big. Let's see. Do you have my website? I can't remember since I never call it up. Michael.ords, OARDS.com, I think.
Yes. Yeah. So I have it in the video. You're right. Michael.ords.net. So check out.
And by the way, I need to add that I have 2 ebooks for them. And in another section under resources, which my son, the webmaster, says it'd take a lot of effort to change, I have a 21,000 word article on impacts as a model or submodel for the flood, submodel to catastrophic plate tectonics, all about the impact model.
Awesome.
You can see under resources. And so it's got some of my resources I've published, and under that it has it. I wish we had another place to put it, but that's where you can find it and learn about what I believe how important impacts are in the flood.
You also said that Creation Ministries should be putting out a new book soon, a simplified version of the Ice Age, if I heard you correctly.
Yes, on the Ice Age. Should be out any day, as well as the Ice Core. I got 2 of them coming out supposedly this month on the Ice Age. And the Ice Age is a little more in depth, but not too much. It's pretty much simplified. And the one on Ice Cores is for laymen. And the one I'm doing for caves this winter is supposed to be geared for middle schoolers.
You're going to have to give them a degree in chemistry first. Then you can make you can do it. Again, as I was saying when you ended your presentation, I like the way you lay them out. It also leaves us in suspense where we're thinking, oh no, how can we address those challenges? And then what do? You address the challenges. So that's good. Behind me, I've got a couple of your books. So over here to the left, I got your Frozen in Time. Over here, I got Biblical Geology. Excellent book. Rob Carter put out a new one, Biblical Biology, which I'm waiting for. I can't wait for it to come in.
Yeah, I'm going to get it soon.
Yeah, I'm excited. I ordered it, so it should be here anytime. And then to my left, you edited this one, I think. It's called Rock Solid Answers.
Yes.
And you got rock solid answers in there, Mike.
Yeah.
You named the book correctly. Okay, well, this has been great. Lots of good, solid, positive feedback from our chat, including from the critics. Some of the critics are saying they disagree, but they appreciate you. They appreciate the discussion. So,
well, thank you. I'm glad you're listening. And we can have a nice discussion without any arguments.
Exactly. Yelling and name calling.
Yes.
And all of that, which does happen. So, okay, Mike. Well, again, thank you so much for your time. To the audience, thank you so much for tuning in. I appreciate all the interaction, the engagement, the support, the questions, the challenges. That's what we are here for, to uphold the truth of biblical creation and address your questions, address your challenges. So, Mike, God bless you. To the audience, God bless you as well. I hope you had as much fun as I did. Standing for Truth is out.